A 2,000-year-old water system still flows perfectly today. These ancient infrastructure systems are not abandoned ruins. They are fully operational marvels that defy our modern expectations of how long things should last. By the end of this journey, you will know the secret principles that allowed 20 of these hidden wonders to survive for millennia. We will explore how a Roman harbor strengthens in seawater and why a desert civilization built spiral wind pumps deep underground. These silent, enduring structures hold untold stories of ingenuity, challenging everything we think we know about technological progress. What does it truly mean to build something that lasts forever? Our modern world runs on digital blueprints and power tools, but the foundations for structures that last 1,000 years were laid with entirely different principles. Ancient engineers worked with the land, not against it. They possessed an intimate knowledge of local materials, understanding which stones resisted erosion, how clay could be sealed to hold water, and which timbers would endure. This was not a matter of brute force. It was a refined craft born from generations of observation. A builder would know the exact angle to cut a block so it locked perfectly with its neighbor, or how the seasonal path of the sun could be used to naturally cool a building's interior. Their tools were simple, but their understanding of physics and geology was profound. They saw a river not just as water, but as a force to be channeled. They viewed a hillside not just as an obstacle, but as a potential support wall. This deep connection to their environment meant every project was a collaboration with nature itself. The drive for these monumental works was always rooted in survival and community. A city needed a reliable water source to flourish. Trade routes required safe harbors and durable roads. This necessity sparked a creativity we still struggle to replicate today. They planned for futures they would never see, investing immense labor in projects meant to serve their grandchildren's grandchildren. How did they achieve such foresight without our technology? The answer lies in a patient, cumulative knowledge passed down through stories and apprenticeships, where every failure taught a lesson and every success became a new standard. This foundational wisdom is the invisible blueprint behind every lasting structure we are about to explore. Deep beneath the sun-scorched deserts of Iran, a hidden river flows in silence. This is not a river of legend, but a masterpiece of engineering known as the Qanat. For over 3,000 years, these gently sloping tunnels have been carrying precious groundwater from the foothills of mountains to the arid plains below, solely using the unerring pull of gravity. The journey of a Qanat begins with a mother well painstakingly dug deep into an underground aquifer. From this source, a master tunnel is carved, descending at a slope so precise that the water within it moves steadily for many kilometers without ever slowing or stagnating. Can you envision the patience required to chart such a course through solid rock and earth, with only simple tools and profound understanding to guide the way? To construct and maintain this life-giving artery, vertical shafts were sunk from the surface down to the tunnel at regular intervals. These openings provided air for the dedicated workers, the mucanis, and allowed them to remove debris during the initial dig. But their genius extended far beyond construction. In a desert climate where the sun can steal a pond in hours, the Qanat's entire design is a defense against loss. By moving water deep underground, it is shielded from evaporation, ensuring that every drop from the mountain aquifer reaches its destination. This reliable supply did more than just quench thirst. It allowed agriculture to bloom in the desert and sustained great cities, with some of the oldest systems, like those in Qanat, still in perfect working order today. The Qanat is more than a water channel. It is a silent tribute to a civilization that viewed water not as a resource to be conquered, but as a partner to be guided. It stands as a powerful question to our modern world. What can we learn from an infrastructure that has functioned flawlessly for millennia, not in spite of nature, but in perfect harmony with it? While the Qanat worked in hidden silence, another civilization chose to build its water system as a public monument to human triumph. Soaring above the modern streets of Segovia, Spain, the Roman aqueduct is a breathtaking spectacle of raw power and grace. Its massive granite blocks climb skyward in 2 tiers of perfect arches, an astonishing feat when you realize not a single drop of mortar holds them together. This is not merely a ruin. For nearly 2,000 years, this structure was a working artery, carrying water from the Frio River over 15 kilometers to the bustling Roman city. Its entire function relied on a secret hidden in plain sight, a gravitational slope so precise and gentle that the water flowed effortlessly the entire distance. How did they achieve such accuracy over such rugged terrain, using only simple tools and brilliant calculation? The answer is locked in the stones themselves. Each block was cut with masterful precision, creating a perfect friction fit that transfers weight and force evenly across the entire structure. Think of it as a colossal stone puzzle, where every piece supports its neighbor, creating a unified whole that has withstood earthquakes, wars, and centuries of weather. This balanced distribution of force is the reason it remained in active use well into the 20th century, even as the modern city grew around it, with buildings pressing against its very base. The aqueduct endured. It stands as a powerful lesson in elegant design, proving that the most resilient solutions are often born from simplicity and a deep understanding of natural principles. The Romans did not just build a water channel, they built a legacy in stone, challenging us to consider what we are building today that will still stand fully functional 2,000 years from now. But even a towering aqueduct is vulnerable to an enemy who can cut its source. The true test of an infrastructure is not just how it delivers, but how it protects. Far below the vibrant chaos of modern Istanbul, a silent, flooded palace holds the answer. This is the Basilica Cistern, a testament to survival built by Emperor Justinian in the 6th century. Step inside and you enter an upside-down world. The air is cool and carries the gentle sound of dripping water. Above, a ceiling of arched brickwork is mirrored perfectly in the vast, dark pool below, held aloft by a forest of 336 marble columns. It feels less like a storage tank and more like a sunken cathedral dedicated to the very essence of water. This aquatic fortress was designed to hold an almost unimaginable 80,000 cubic meters of water, enough to sustain the great palace of Constantinople through years of siege or devastating drought. Its water was channeled from aqueducts drawing from forest sources over 19 kilometers away, a lifeline secured against any threat. Every aspect of its construction speaks to a profound practical wisdom. The roof was built with fire-resistant bricks and sealed with a special waterproof mortar, while many of its magnificent columns were cleverly repurposed from older Roman ruins, a masterclass in sustainability. For centuries, this monumental achievement was lost to memory, its entrance hidden beneath a simple basement. Then, it was rediscovered, its waters carefully drained to reveal a time capsule of engineering genius. Today, visitors walk on raised platforms where boats once glided, and the space even hosts concerts, its acoustics enriched by the water that still seeps through its ancient walls. The Basilica Cistern is more than a relic. It is a hidden aquatic sanctuary that solved one of history's greatest urban challenges, proving that true security often lies not in what is visible, but in what is profoundly, secretly, and enduringly preserved. High on the windswept Bolivian Altiplano, the stones of Tiwanaku hold a secret deeper than any temple. The city's iconic Gate of the Sun, a monumental archway carved with a complex celestial deity, is far more than a spiritual symbol. It is the centerpiece of a hydrological masterpiece, a key component in an intricate drainage network that has defied centuries of torrential rain. The entire ceremonial core was raised upon a vast, engineered platform, a foundation riddled with subterranean stone conduits. These channels, carved from perfectly fitted andesite blocks with seams so tight a blade cannot slip between them, were designed to manage the immense volume of water from seasonal downpours and the nearby expanse of Lake Titicaca. How did a culture with no written language conceive of such a precise and enduring hydraulic system? The answer flows through the very layout of the city itself. Every plaza, every mound was angled and shaped to guide water into this hidden network, preventing destructive floods and preserving the sacred heart of the metropolis from erosion. This was infrastructure woven directly into the urban fabric, an invisible shield against the elements. Recent research points to a purpose even more profound than simple utility. Water was not merely a physical force to be controlled. It was a sacred element, and the movement of these channels likely mirrored spiritual beliefs, turning the entire city into a living representation of their cosmology. The rain that fell from the heavens was not wasted. It was ceremoniously channeled through the stones, perhaps in rituals performed under the gaze of the sun gate's carved god. This seamless fusion of practical engineering and spiritual meaning created a system that was cared for, maintained, and respected. That is why, over 1,000 years later, these ancient drains still function exactly as their builders intended. They stand as a powerful reminder that the most sustainable infrastructures are those that are not just built efficiently, but are also woven into the cultural and spiritual identity of the people they serve. 2.5 centuries before the Common Era, a Chinese governor faced an impossible task. The Min River was a dragon, its seasonal floods drowning farms and villages, while its low waters brought drought and famine. Governor Lai Bing was ordered to tame it, but he rejected the conventional solution of building a dam. Instead, he conceived of something far more brilliant, an irrigation system that would dance with the dragon rather than fight it. The result was Dujiangyan, a living, breathing infrastructure that has managed the river's flow for over 2,200 years and continues to water a vast agricultural heartland today. How did he achieve this? The system's genius lies in 3 simple, perfectly coordinated components that work with the river's own energy. First, a man-made levee called the Yuzui, or fish mouth, was constructed midstream. This division is not a barrier but a guide. It splits the river into an inner channel that carries clear water and an outer channel that flushes away heavy sediment, a natural sorting process that happens with every current. During the high waters of the rainy season, the outer channel safely carries away 60% of the flow, preventing catastrophic floods. In the dry season, the proportions reverse, ensuring 60% of the precious water flows into the inner channel for irrigation. This is not a static structure, it is a dynamic conversation with the river itself. The second component is the Fascian, or flying sand spillway. This is the system's pressure valve, an overflow channel that automatically diverts excess water and the suspended silt it carries back into the main river. When the water level rises too high, it simply spills over this low embankment, protecting the plains downstream from inundation. The final piece is the Bayapinku, the precious bottleneck, a carefully carved channel through a mountain that draws the now clear water into a sprawling network of canals. This narrow entrance acts as a natural check, controlling the volume of water entering the irrigation system. The entire design is a symphony of ecological engineering, one that has avoided the siltation that eventually chokes most dam-based systems. To stand at Dujiangyan today is to witness a principle in action, a philosophy etched into the landscape by Lai Bing. He left behind a simple, 6-character instruction for all future maintenance, a mantra for sustainable engineering. It translates to, dig the channels deep, keep the weirs low. This wisdom ensured that each generation would work with the river's nature, not against its power. The system still nourishes over 5,300 square kilometers of farmland, supporting millions of people. It asks us a profound question, one that echoes from the Qanats of Iran to the aqueducts of Rome. Are our modern megaprojects truly more advanced, or have we forgotten the subtle art of listening to the world we are trying to shape? While the Chinese danced with a river dragon, another civilization faced an even more formidable opponent, the relentless dryness of the Peruvian desert. Here, the Nazca people did not just find water, they coaxed it from the earth using the very wind that scorched their land. Scattered across the hyper-arid plains are strange, spiraling stone holes that descend into the ground. These are the Puquios, and they are not merely wells, they are sophisticated wind-powered pumps, an ancient technology that still breathes life into the desert today. The principle is one of elegant physics. As the dry desert wind whips across the landscape, it is funneled down the spiraling ramps of the Puquio shaft. This design forces the air to accelerate, creating a powerful pressure difference at the bottom. That drop in pressure acts like a gentle, constant siphon, pulling precious groundwater up from the hidden aquifer below and into a connected network of horizontal tunnels. From there, the water flows to the surface, emerging in sun-drenched oases. The sheer brilliance of this system lies in its passive operation. It requires no fuel, no moving parts, just the ceaseless energy of the environment itself. Building it, however, demanded a knowledge so intimate it borders on the mystical. Without modern drilling equipment, how did the Nazca know exactly where to dig to intercept the water table? They had to understand the subtle whispers of the land, reading the geological strata and hidden water veins with an accuracy that still baffles engineers. This mastery over their brutal environment was the foundation for everything they achieved. It was this reliable water, drawn from the Puquios, that sustained the population and provided the labor force necessary to create the vast and mysterious Nazca lines. Those immense geoglyphs etched into the desert floor, visible only from the sky, are a testament to a society that had conquered its most basic survival challenge. The true wonder is that this ancient ingenuity is not locked in the past. Local communities continue to maintain and use many of these puquios, channeling the water for their crops just as their ancestors did. It is a living dialogue with the past, a sustainable system that has quenched thirst for over 2,000 years. In a world searching for green solutions, the Puquios stand as a quiet monument to a simple truth. The most advanced technology is often the one that listens to the world and works with its endless rhythms. High on the sun-baked mesas of Colorado, an entire civilization chose to live within the cliffs. The ancestral Pueblones built their intricate stone cities deep inside canyon alcoves, not as a retreat from the world, but as a brilliant strategy for survival. In this semi-arid landscape, their most precious resource was not the stone for their walls, but the water that fell from the sky. Their greatest architectural marvel, therefore, was not the dwellings themselves, but the hidden veins that gave them life. They engineered the entire mesa top into a vast, sloping catchment basin. When the rare rains came, they did not simply trickle down the rock face. A meticulously planned network of sandstone channels, carefully pecked into the cliffside, captured the runoff. These channels guided every precious drop away from the cliff dwellings to prevent erosion, and instead funneled it directly into hand-carved, clay-lined cisterns nestled safely within the villages. Can you visualize the foresight this required? They were not just building for a single storm, but for generations of drought. Their understanding of hydrology was so refined that they even incorporated a simple yet effective form of water treatment. Certain channels were designed with subtle dips and turns, areas where the water would slow just enough for sediment and debris to settle out. By the time the rainwater reached their storage jars, it was remarkably clear, a testament to their concern for health and purity. This passive filtration system required no moving parts, only a profound understanding of how water behaves. The infrastructure was so perfectly integrated with the natural landscape that its legacy endures. Even after 8 centuries, the subtle pathways they carved into the sandstone still guide rainwater along its intended course. The cliff dwellings of Mesa Verde stand empty now, but the silent, functioning echo of their water system remains. It speaks of a culture that did not merely endure a harsh environment, but learned to read it with such intimacy that they could coax sustainability from the rock itself. Their achievement challenges our own relationship with resources. In an age of complex machinery, what does it mean that the most enduring solutions are often the simplest, the ones that work with the unerring logic of the land? Stones worn smooth by 2,000 years of footsteps still guide the rain. On a windswept moor at Blackstone Edge in England, a ribbon of Roman paving remains perfectly intact, its surface grooved by cartwheels and flanked by deep drainage gullies that function as flawlessly today as they did when legions marched across Britain. This is not a relic preserved behind a fence. It is a working piece of infrastructure, still performing its primary duty of shedding water and resisting erosion long after the empire that built it vanished. The secret to this unbelievable longevity lies in what is hidden beneath the surface. Roman engineers did not simply lay stones on the ground. They built a complex, multi-layered foundation that acted like a suspension system for the entire road. First, they dug down and laid a bottom stratum of large, packed stones for stability. On top of this, they placed a middle layer of smaller rocks and rubble, which locked together to distribute weight and provide drainage. Finally, the visible surface was crafted from tightly fitted, hard paving stones, each one carefully chosen and shaped, but the final masterstroke was the road's crown. The surface was subtly arched so that any rainfall would naturally run off into those deep side ditches, preventing water from pooling and softening the ground beneath. This was an all-weather highway designed for the relentless march of soldiers and the heavy rumble of supply carts that fueled an empire. Think of the foresight this required. They were not building for a decade or even a century. They were building for a future they would never see, investing immense labor in a network meant to bind continents together. The continued functionality of these roads, especially their drainage, is a silent testament to a standard of engineering that has outlasted countless modern asphalt surfaces, which crack and degrade under the very same forces of nature. These enduring pathways are more than just stone. They are the bones of the empire still lying beneath our feet, asking us what we are building now that will still serve its purpose 2 millennia from now. This relentless pursuit of permanence in stone and water finds a startling parallel in a city that learned to float upon a swamp. Deep beneath the modern streets of Malta, in a darkness untouched by the sun for thousands of years, sound takes on a life of its own. The Saflieni Hypogeum is a labyrinth of halls and chambers carved directly into the living limestone, a subterranean world created over 5,000 years ago. While its primary purpose was as a final resting place, Its true marvel lies not in the silence of the stones, but in a voice they were designed to amplify. One chamber, known today as the Oracle Chamber, is an acoustic masterpiece. When a specific low-frequency sound is made within this space, something remarkable happens. The sound does not merely echo, it amplifies, swelling to fill the entire chamber with a resonant hum that vibrates through the very air and stone. Modern visitors describe feeling this resonance in their bones, a physical sensation from a voice cast millennia ago. This was no accidental feature. The prehistoric builders carved the chamber with a precise, parabolic shape, creating a perfect resonating cavity. They understood the properties of their limestone canvas, knowing exactly how to sculpt it to trap and magnify sound waves. This engineered sonic environment was a critical piece of their spiritual infrastructure, a technology that likely transformed ritual chanting or drumming into an overwhelming, otherworldly experience meant to connect the physical and spiritual realms. The preservation of this precise acoustic property for over 6,000 years, through shifts in climate and the gentle decay of time, is a testament to a sophistication we are only beginning to comprehend. It forces us to expand our definition of ancient infrastructure. It was not always about channeling water or supporting weight. Sometimes it was about channeling belief itself, using the hidden physics of sound to build a bridge to the divine. This hidden power of a single, perfectly tuned note invites us to listen more closely to the silent stones of other ancient sites, wondering what other sensory engineering marvels are waiting to be heard. A fortress must first be a wellspring. High in the arid hills of Mycenae, the legendary seat of Agamemnon, survival depended not only on towering walls but on a hidden artery. Deep beneath the Lion Gate, a monumental aqueduct engineered from stones so vast they were later thought to be the work of mythical giants, the Cyclopes, channeled a perpetual flow of fresh water. This was no simple ditch. For over a kilometer, the Mycenaeans carved a graded tunnel and constructed covered passages, guiding water from a distant spring directly into the heart of their citadel. Can you picture the strategic genius? In an era of constant conflict, they secured their most vital resource against both the elements and any army that might lay siege. The water flowed unseen and protected, a clandestine river ensuring the kingdom would not fall to thirst. The engineering itself is a marvel of balanced force. Using a corbelling technique, they stacked massive limestone blocks, each layer projecting slightly inward over the one below. This created a soaring, vaulted channel locked together by gravity and friction alone, a testament to a stonemason's art that required no mortar. The structure distributes weight and stress so perfectly that it has shrugged off earthquakes and 3,000 years of weathering. Sections of this Bronze Age conduit remain astonishingly intact, its internal passageway still clear. The principles it demonstrates, a consistent gravitational slope to maintain flow and a protected path to ensure purity, are fundamentals still taught to hydraulic engineers today. This hidden infrastructure was the silent guarantor of Mycenaean power. It allowed the city to flourish behind its formidable defenses, supporting a population of artisans, warriors, and rulers for centuries. Its enduring stones ask us a simple, profound question. What does true security look like? Is it the visible fortification, or is it the secret, life-giving system that flows steadily on, long after the gates have fallen silent? Descending into a stepwell is like walking into the Earth's own cathedral. Across the arid plains of India, these magnificent structures, known as baolis, are far more than simple wells. They are ornate, multi-story subterranean palaces carved entirely in reverse, their intricate pillars and hundreds of steps reaching down to greet the rising water table. A structure like Rani Kai Vav in Gujarat, built in the 11th century, is a testament to this breathtaking vision. It is a 7-story complex of precisely carved pavilions, galleries, and more than 800 steps, all designed to accommodate the dramatic seasonal fluctuations of the groundwater. During the dry season, one would descend past countless sculptures and colonnades to reach the receding water. In the monsoon, the lower levels would slowly flood, transforming the space into a kind of inverted temple. The engineering that enabled this was as sophisticated as the artistry. The entire structure was a hydrological machine, with hidden drainage channels and filtration systems built directly into the stone walls. Sand and charcoal layers within the steps would naturally purify the percolating rainwater, ensuring the community's water supply remained relatively clean. This subterranean design was also a masterstroke of climate control. While the surface baked under the sun, the temperature deep within the baoli could drop by 10 degrees or more, creating a cool, tranquil oasis for gathering, for ritual, and for simple respite. After centuries of disuse, many of these stepwells are now being lovingly restored, and every monsoon they demonstrate their enduring genius, filling with water exactly as planned, their structural integrity preserved by the flawless interlocking stonework that needs no mortar. They stand as a beautiful fusion of absolute utility and profound art, reminding us that the most vital infrastructures are those that also nourish the human spirit, turning the simple act of drawing water into a communal ceremony. The same principles of interlocking stone that built roads and stepwells found an earlier, more intimate application deep within the Minoan palace of Knossos. Here, a hidden network of terracotta pipes, dating back over 3,700 years, reveals a society that mastered the flow of water not just for survival, but for comfort and health. These were not simple clay conduits. Each pipe was ingeniously tapered, designed to fit snugly inside the next, creating a seal that increased water pressure and minimized leaks with an efficiency that would not be out of place in a modern home. Can you hear the faint echo of water rushing through these ancient corridors, a sound of remarkable foresight in a Bronze Age world? This was a complete hydraulic system. It channeled fresh water from mountain springs directly into the palace's ceremonial baths and residential quarters, while a separate, sloped network of drains efficiently carried wastewater away. The most astonishing evidence of this is a small, flushed terracotta seat, considered one of the earliest known toilets, complete with a wooden overhead reservoir for cleansing. This was not merely a luxury. It was a profound innovation in urban sanitation, a concept of public health that would be lost and then rediscovered millennia later. The Palace of Knossos may stand in ruins today, its vibrant frescoes faded, but the underlying concept of its plumbing remains perfectly sound. The Minoans understood that a thriving civilization required an invisible backbone, a system to manage purity and waste long before such ideas became commonplace. Their terracotta pipes, hidden beneath the floors, were the silent guardians of well-being, a testament to an engineering spirit that valued the health of the community as much as the grandeur of its monuments. This early pursuit of cleanliness and comfort challenges our timeline of progress, asking us why such a fundamental advance had to be repeatedly forgotten and then reinvented across the ages. High above a dizzying Andean gorge, a bridge of woven grass sways gently in the mountain wind. This is the Qanat, a suspension bridge that has connected the Inca Empire for centuries, not as a static monument, but as a living, breathing ritual. Every single year, the local communities from 4 villages gather for a 3-day festival of communal engineering. They do not repair the old bridge, they completely rebuild it from scratch, using the same techniques and the same material, iku grass, that their ancestors used. The process begins with the harvesting of the tough grass, which is then soaked and pounded to make it pliable. men and women work together, twisting the fibers into thin cords, which are then braided into 6 massive support cables. Can you envision the trust required to walk across a chasm on a structure made entirely of grass? The secret lies in the Incas' profound understanding of tensile strength. The grass fibers, when woven together into ever thicker ropes, create a cable that is incredibly strong for its weight, capable of flexing with the wind and the footsteps of travelers without snapping. This design is so effective that the rebuilt bridge safely carries people and even livestock across the Apurimac River Canyon today. But the true genius of this infrastructure is not merely in its physical form. The annual renewal is a sacred duty, a ceremony that weaves the community itself back together. The specialized knowledge of knot tying, cable braiding, and anchor construction is passed from elders to the youth, not through blueprints but through shared action. This living bridge is a powerful symbol of continuity, proving that the most resilient structures are those that are not just built to last, but are continuously reborn through collective memory and purpose. It asks us a profound question about our own concrete and steel world. What is the true cost of a permanent structure if its construction severs the very social bonds that give it meaning? Far out in the Caspian Sea, a city of iron rises from the waves. Neft-Dashlari, meaning oily rocks, is a Soviet-era marvel that began as a single offshore platform in 1949 and grew into a sprawling, functional town perched on a web of trestles and bridges stretching over 300 kilometers. This is not a ruin rusting away in solitude. It is a living, breathing settlement with apartment blocks, a bakery, and a cultural center, all standing on thousands of piles driven deep into the seabed. How does a city of steel, exposed to the relentless saltwater and punishing winds of the Caspian, continue to house workers and pump oil more than 7 decades after the first pillar was sunk? The answer lies in a brutalist form of foresight. The original builders used massively over-engineered steel frames and dense, sulfate-resistant concrete, materials chosen to withstand an environment they knew would be merciless. There were no delicate solutions here, only a profound understanding that the sea would test every weld and every joint without reprieve. The entire complex was designed as a flexible network, allowing sections to shift and settle without catastrophic failure. This is a modern-day echo of the same principle that kept Roman roads intact, a resilience born from respecting the power of the natural world rather than attempting to completely subdue it. While the cranes and drilling rigs represent 20th century industry, the silent, enduring struggle between the structures and the corrosive sea is an ancient story. Neft-Dashlari stands as a powerful testament to the idea that the principles of longevity are not locked in the distant past. They are applicable in any era, whenever builders choose to invest in materials and designs meant to outlive them. This hidden industrial world, still functioning long past its expected lifespan, challenges our modern notion of planned obsolescence. It asks us to look at our own sprawling infrastructures and wonder, what have we built in the last 70 years that has even a fraction of this stubborn will to endure? A hidden river flows beneath the scorching sands of the Turpan Depression, one of the hottest and driest places on Earth. This is the Carrez, a subterranean labyrinth of wells and tunnels that has sustained life here for more than 2,000 years. Imagine the profound collaboration this system represents, a network so vast it rivals the Great Wall and the Grand Canal as one of China's 3 legendary ancient projects. Its genius lies in a simple yet breathtakingly difficult principle. Workers first dug a mother well deep into the underground aquifer, fed by the distant, snow-capped Chanshan Mountains. From this source, they would then carve a master tunnel, sloping with an almost imperceptible gradient back toward their settlements. To construct this gently falling channel, sometimes stretching over 30 kilometers, they sank thousands of vertical shafts from the surface. These shafts provided air, allowed for the removal of rubble, and served as vital maintenance access points for generations. In a desert where the sun can vaporize a surface canal in hours, the entire carrez is designed to hide the water from the sky, delivering it cool and clean to the oasis fields. The precision involved is staggering. How did surveyors without modern tools chart a course that dropped only a few centimeters every kilometer, ensuring a steady, unceasing flow powered only by gravity? The answer is a cumulative wisdom passed down through countless hands, a deep, intuitive understanding of the land's hidden contours. Today, this hidden lifeline continues to water the vineyards and fields of the Turpan region, supporting the Inca communities who have maintained it for centuries. It stands as a powerful parallel to the Qanats of Persia, a testament to a universal human truth. Across continents and cultures, when faced with the ultimate challenge of survival, the greatest minds turned not to conquering the desert, but to coaxing a river from the stone beneath it, building a legacy that endures not in spite of the elements, but because it respectfully yields to their power. While the carrez flows hidden beneath the desert, another ancient innovation thrives in plain sight beneath the waves. Submerged along the Mediterranean coast, the skeletal remains of Roman harbors perform a quiet miracle. At Caesarea Maritima, massive concrete breakwaters lie just below the surface, their surfaces etched by 2,000 years of seawater. Yet these stones are not slowly eroding. They are growing stronger. The Romans crafted a maritime concrete unlike anything we use today, a mix of volcanic ash, lime, and rubble that held a secret only the sea could unlock. When this unique blend is submerged, the saltwater triggers a slow, miraculous chemical reaction. Instead of corroding the material, the water crystallizes a rare mineral called aluminous tobamorite within the concrete's matrix. Think of it as the stone growing its own reinforcing fabric, a crystalline web that actually resists cracking and becomes more resilient with each passing century. This is not a material that simply endures the elements. It collaborates with them, using the ocean's own chemistry to perpetually repair and strengthen itself. The wooden piers and grand buildings that once stood upon these foundations are dust, but the concrete cores remain fully functional. Even now, they mitigate the force of waves, silently protecting the modern coastline they were originally built to serve. Modern scientists, armed with advanced microscopes, are only just beginning to decode the complex geochemistry the Romans mastered through sheer empirical genius. Our own Portland cement, the backbone of modern construction, often crumbles in saltwater within decades. This ancient smart material represents a lost technology, a pinnacle of materials science that in some ways remains superior to our own. It poses a humbling question to our era of rapid innovation. Have we, in our rush for the new, forgotten how to build a dialogue with the very forces that seek to destroy our creations? The harbor concrete does not defy the sea. It welcomes it, and in that embrace finds a strength that has lasted for millennia. A natural well plunges into darkness, its waters stained deep green by the jungle canopy above. This is the sacred cenote at Chichen Itza, a place long shrouded in tales of ceremonial offerings. Yet beneath that powerful surface lies a story of hydrological genius that transformed a sinkhole into a managed resource. The Maya did not simply find a water source, they engineered it. They constructed stone platforms and carefully graded channels around the cenote's rim, creating a sophisticated system to regulate its water level. This was not an attempt to control the water's source, for it was fed by vast, hidden underground rivers. Instead, it was an effort to manage its presence, to create stable access points, and perhaps even shape the theatrical stage for their most profound rituals. The entire city was laid out in relation to this and other cenotes, a planned network of both practical water sources and spiritual gateways. The engineering itself was a quiet marvel, a perfect adaptation to the unique karst landscape. The limestone, porous and riddled with natural drainage, was not a barrier to be overcome. It was a partner in the design. The Maya channels and platforms worked with this geology, guiding runoff and stabilizing the treacherous edges of the sinkhole. This subtle, respectful interaction with the land is why the system has remained a focal point for over 1,000 years. The underground rivers continue their silent flow, and the cenote's waters persist, a testament to an infrastructure that was never meant to dominate nature, but to honor and collaborate with it. The true legacy of the sacred cenote is this blurred line between the spiritual and the practical. It challenges our modern categorization of what constitutes infrastructure. For the Maya, a water management system was not separate from their cosmology. It was a physical expression of it, a sacred hydrology where every channel served the community and every drop of water carried meaning. This deep intertwining of culture and engineering created a system that was not just built to last, but was cared for, revered, and ultimately sustained by the very beliefs it helped to uphold. A mortar made from egg whites and goat hair binds the stones of a bridge that remembers two lives. The original Stari Mos arched gracefully over the Neretva River for 427 years, a slender stone thread connecting communities. Its single span was an audacious feat of 16th century Ottoman engineering, a humpbacked arc of local teneliger stone that seemed to defy gravity. Then, in the conflict of the 1990s, it was gone, collapsing into the green waters below. But the story of this bridge was not over. Its destruction sparked a global resolve not merely to rebuild, but to resurrect. The new millennium saw a monumental act of archaeological engineering, as divers plunged into the cold river to recover the original, weathered blocks from the riverbed. Master masons, inheritors of ancient techniques, studied the old ways to cut and shape new stones, mixing a special lime mortar whose recipe was a carefully guarded secret. The reconstruction was not a modern simplification. It was a painstaking act of cultural memory, a deliberate choice to trust the original design principles that had proven their worth for centuries. Can a bridge be more than its physical form? The people of Mostar would say yes. The new Stari Mos, completed in 2004, is a testament to that belief. While the stones are younger, the soul of the bridge is ancient. Its graceful arch performs the same function, creating the same vital pedestrian link across the river. It has reclaimed its role as a symbol of unity, a platform where divers still leap into the currents below, a ritual of continuity that mends the tears of history. The bridge's rebirth teaches a profound lesson about resilience. It proves that the most valuable aspect of ancient infrastructure is not the stone itself, but the timeless intelligence of its design. When a community chooses to rebuild using the original blueprint, they are not just restoring a structure, they are reaffirming a promise to the future, one carved from the enduring wisdom of the past. Beneath the weight of the world's largest Roman temple, a hidden river of stone still flows. The colossal columns of the Temple of Jupiter at Baalbek stand on a podium of monumental blocks, but their true support lies deeper still, in a labyrinth of vaulted tunnels and masterful drains. While visitors gaze upward at the scale of the ruins, the real secret to their preservation is found in the cool, dark passages under their feet. The Romans, building upon even older sacred foundations, engineered this subterranean network to be a permanent shield against the temple's greatest enemy, not invading armies, but the slow, insistent power of water. They carved massive stone conduits and channels with a precise, consistent slope, ensuring that every drop of rainwater and every trickle of groundwater would be captured and guided away from the foundations. Can you conceive of the foresight required to protect a structure not for a century but for millennia? This was not an afterthought. It was a fundamental principle of their architectural philosophy. A building's longevity was determined as much by what lay beneath it as by the grandeur of what stood above. The system worked so perfectly that it has prevented the soil erosion and structural weakening that have toppled countless other ancient monuments. Even as earthquakes shook the land and conflicts swirled overhead, these silent stone veins continued their work, channeling water away from the podium that holds the fabled trilithon, 3 stones each weighing over 800 tons. The continued functionality of this 2,000-year-old drainage network is the primary reason these ruins remain so breathtakingly intact. It is a profound lesson in invisible engineering. The true marvel of Baalbek is not just the visible spectacle of its columns, but the unseen, enduring intelligence that has steadfastly preserved them, a reminder that the greatest monuments are always supported by foundations we never see. The sea itself became the final guardian of a city's blueprint. Submerged just 4 meters beneath the calm bay off the coast of southern Greece, the sunken city of Pavloptri rests in a silence broken only by the shifting light of the water. Dating back at least 5,000 years to the Bronze Age, this is not a jumble of forgotten ruins. From above, the view is astonishing, a complete urban grid preserved as if in a vast, liquid museum. The skeletons of streets still run straight between the foundations of buildings. The outlines of courtyards and tombs remain perfectly clear. This is a fossilized metropolis, a master plan captured at a single moment and held in perpetual stasis by the very sea that claimed it. How did a city's entire lay outsurvive 5 millennia of tides and saltwater when so many later constructions have turned to dust on dry land? The answer lies in the quiet genius of its original placement and the gentle chemistry of its burial. Built upon a naturally sheltered, sandy bay with a stable limestone bedrock, the city's foundations were laid with an intuitive understanding of the landscape. When sea levels rose slowly over the centuries, the fine sediments of the seafloor gently blanketed the city, protecting its stonework from the full force of erosion. This process did not destroy the city, it preserved it, creating a perfect archaeological time capsule. The grid reveals more than just streets, it shows evidence of a sophisticated approach to communal living. Researchers have identified what appear to be channels and cisterns integrated into the urban plan, a clear indication that its inhabitants had engineered solutions for fresh water supply and drainage. This was a society that, from its very inception, planned for the health and functionality of its community. They carved a civilization that considered the flow of water and the movement of people as fundamental to its design. Pavloptri's enduring footprint offers a unique window into the prehistoric mind, a glimpse of the moment our ancestors first conceived of a city, not just as a collection of homes, but as a single, interconnected organism. Its silent, sunken streets ask us a final, haunting question about all the enduring systems we have explored. What will remain of our own cities, and what will their foundations say about us when 5,000 years of silence have passed? These 20 hidden systems, scattered across continents and millennia, all whisper the same fundamental truths. The first and most vital principle is a profound collaboration with nature. From the Qanat's gentle gravitational slope to the Dujiangyan's dance with the river dragon, these builders saw the environment not as an adversary to be conquered, but as a partner with its own powerful logic. They harnessed gravity as their perpetual engine, used wind as a pump, and understood groundwater flows with an intimacy we can scarcely imagine. This was not primitive guesswork. It was a sophisticated science of observation, a deep reading of the land that allowed them to build infrastructures that the earth itself would help to sustain. The Roman concrete that strengthens in seawater is the ultimate example of this, a material that does not resist the ocean but invites it in, transforming a corrosive force into a source of perpetual renewal. Simplicity and robustness form the second universal thread. The most enduring solutions are often startlingly straightforward. The perfect friction fit of Segovia's aqueduct, the massive interlocking stones of Mycenaean's aqueduct, the woven grass cables of the Qanat bridge all share a common theme. They rely on fundamental physical principles and oversized, resilient materials, creating structures with very few points of potential failure. There are no delicate moving parts to rust, no complex electronics to fail. This inherent redundancy and strength mean that when a single component is stressed, the entire system shares the load. It is the difference between a modern chip that fails with one tiny flaw and a stone wall that can lose a block and still stand firm for centuries. This robust design philosophy prioritizes long-term function over short-term efficiency, a trade-off that has proven its worth across 3,000 years. Yet even the most perfectly designed stone cannot maintain itself. The third essential element is the human hand and heart. These systems survived because they were woven into the cultural and spiritual fabric of their communities. The annual rebuilding of the Qanat bridge is a sacred ritual that binds villages together. The stepwells of India were not just water sources but cool, communal gathering places and artistic treasures. This cultural value created a powerful incentive for preservation, fostering a living chain of intergenerational knowledge. The Muqannis of Iran, the caretakers of the Khares, the elders teaching the youth how to braid the grass cables, these were the true guardians of longevity. The infrastructure was not an external utility, it was a cherished heirloom, and its care was a duty passed from parent to child. This culture of preservation ensured that the wisdom of the original builders was never truly lost. All of this points to a final, defining mindset, a perspective almost foreign to our modern world, the long-term view. The builders of the Roman roads, the planners of the Khares canals, the masons of Baalbek, they invested immense labor in projects they knew they would never see completed. They were planting trees under whose shade they would never sit. This was not mere altruism, it was a profound understanding of legacy and continuity. They built for their grandchildren's grandchildren, embedding into their work a resilience meant to outlast empires and languages. This patient, cumulative investment stands in stark contrast to our era of quarterly reports and planned obsolescence. It challenges us to reconsider the very purpose of our own creations. Are we building for a deadline or for the deep time of future generations? The silent, functioning echo of these ancient marvels offers a clear answer, one written not in blueprints, but in stone, water, and the enduring will to build a world that lasts. From the whispering aqueducts of Rome to the living bridges of the Inca, these 20 hidden systems are not relics trapped in a museum case. They are active, breathing lessons in a different way of being, a philosophy of building that challenges the very core of our modern world. We live in an age of planned obsolescence, where devices are designed with expiration dates and infrastructure projects are celebrated if they last 50 years. These ancient wonders stand in silent defiance of that short-term thinking. They prove that with careful thought, a deep respect for natural forces, and an unwavering commitment to quality, human creations can become partners with time itself. Every story we have explored, from the desert-breathing Puquios to the self-healing Roman concrete, is a story of a culture solving its most pressing problems with the tools and knowledge it had. They did not have digital modeling or global supply chains. What they possessed was something perhaps more powerful: a patient, cumulative intelligence passed through generations and a profound understanding of their local environment. This was not a primitive struggle for survival. It was a refined art of collaboration with the world. They left behind a legacy that still functions, that still waters fields and connects communities, long after their languages faded and their empires turned to dust. As we face our own global challenges, from resource scarcity to a changing climate, perhaps the guidance we need is not only in the newest technology, but also in the oldest stones. These systems ask us to build not just for quarterly reports, but for the deep time of our grandchildren's grandchildren. They remind us that true progress is not always about moving faster, but about building things that last. We would love to hear which of these enduring marvels resonated most with you. Was it the hidden rivers of the Carrez or the sonic mystery of the Hypogeum? Share your thoughts in the comments and subscribe for more journeys into the untold stories of our past.